Hi, my name is Femi, and I'll be finishing my video by doing the AP question. The question says, each of 25 adult women was asked to provide her own height, y, in inches, and the height, x, in inches, of her father. The scatter plot below displays the results. Only 22 of the 25 pairs are distinguishable because some of the x-y pairs were the same. The equation of the least squares regression line is y hat equals 35.1 plus 0.427 times x. So what we need to know is that there's only 22 dots here because some of them are the same. Okay, so A says draw the least squares regression line on the scatter plot above. So as you can see here, I already drew my line. How do I do this? Just pick random x values and just plot it in for plot it into the regression line equation and then get a y value. So as you can see here, I did a couple of times right there, and right there. Also right there. And then just kind of connect the dots using a ruler or a straight edge. Okay. Anyways, back to the questions. One father's height was x equals 67 inches, and his daughter's height was 61 inches. Circle the point on the scatter plot above that represents this pair and draw the segment on the scatter plot that corresponds to the residual for it. Give a numerical value for the residual. Okay, so 67 inches, father's height. So each of these are going up by 2. So 67 will be right here, and that's 61 right there. Okay. And then, okay, we circle the point, and then give numerical value for the residual. Okay, so as you can see here, it's below the regression line, so that means it's going to be negative. So what we do to find the numerical value for the residual is look at the regression line. So I'll just write it here. Y hat equals 35.1 plus 0.427 times x. In this case, x is father's height and y is, let's see, woman's height. So in the question it says the father's height was 67. So just plot in 67 for the x value because that's going to be on the regression line. So you would get y hat equals 35.1 plus 0.427 times, say here that's 67 inches. 67. Okay, and then we put this into our data. 35 into our calculator, my bad. 35.1 plus 0.427 times 67. That gives us a y hat value of 63.709. Okay, so that's going to be our regression line value. But here it says that the daughter's height was 61. So the real y value is 61. So what you have to find the regression, oh my gosh, what you have to do here to find the residual is subtract, okay, residual equals y minus y hat. So in this case it would be 61 minus 63.709, which would give us negative 2.61 minus 63.709. Negative 2.709. That's our numerical value for the residual. Okay. C. Suppose the point x equals 64, 84, and y equals 71 is added to the data set. Would the slope of the least squares regression line increase, decrease, or remain about the same? Explain. Okay, so what we do here is just plot it in to this graph right here. This would be 64, and right in between these two lines would be 71. So they cross about right here, which is fairly close to the regression line. So I would say that the regression line stays about the same, because if it's exactly on the regression line, that wouldn't really change the regression line at all. But if it was, say, perhaps above it, like around here or down here, then it would change the line. But since it's already on the line, that makes the regression line true. D. Would the correlation increase, decrease, or remain about the same? Explain. Okay, so both C and D you can do without a calculator. So D, the correlation would increase because you're just adding one more x and y value, so it would have to increase. So that's the AP question for the quiz year chapters 3 and 4. Thank you very much.